Hey everyone, welcome back. So in previous video, we talked about how to build a Streamlit application to have Google's Gemini API back behind it. And as promised, all of the code is released on this GitHub link, and there's an app.py script here, of which you can access the code and reproduce what I did in the previous video. So with that being said, let's jump into the app. The app is essentially ready, right? It's a Streamlit application. It allows me to take any picture and have Gemini analyze the picture. So as I'm playing around with this interaction, I found something very interesting. So let's jump into the app. Here's an app. Of course, I can say, hey, give a thumb up. And the app will take a picture, make an API call to the Gemini's API, and here it will say, hey, there's a young Asian man giving a thumb up. So I thought that was interesting, right? But hey, thumb up is just something fun as an entertainment. How about we do something that's actually interesting that can be helpful for some productionable project? So one thing I found was text extraction, right? So here I have a book, and then I'm going to do a little bit of a promotional video for Pack Publisher. I just take a picture of the book. Let's see what Gemini says about this picture. Now, of course, there's some sort of text, right? And boom, there you go. Look how much information Gemini is able to extract from this picture, right? Let's take a look at this. The picture shows the cover of a book titled Natural Language Understanding with Python. The book is written by Stephen Burr, Ewan Klein, and Errol Loper. So let's take a look. That's where actually the Gemini model started to make a mistake, right? This is what I believe an example of a hallucination. It could have just stopped at the title. It could have just said, oh yeah, this is natural language understanding with Python. Done. Don't say anything else. But what's happening here is it might be looking at a couple of other examples that's related to natural language understanding with Python that turn out that these three names show up. But I can show you guys that the author is actually Deborah. It's not any of these three people. So this is an example where I will call hallucination. And then let's keep reading. It's published by Pack Publishing. That's correct. The book is about natural language processing, NLP. That's correct. And then there's something explaining what that is. Sure, that all sounds correct to me. And then there's a little bit more paragraph explaining what is natural language understanding. So I think all these sounds great. I think what's happening here is, of course, it's a multimodal model. What that means is there's more than one input, right? Picture is just one input. There's probably OCR behind there, right? That's how it recognizes the title, natural language understanding. And then on top of that, there's some sort of search engine behind it, right? That's how it's able to get these names. Although it got it wrong, but still it got some names, right? Hopefully in the future, maybe there's some sort of proofread algorithm behind it or some sort of prevention to stop hallucination, and then perhaps we can get to the right author. And then another thing is, this book actually just came out a few months ago, and it may or may not be popular on the internet yet. So that could be another reason how Google's Gemini got this part wrong, because it could be looking at the database 4 years ago, right? And these three names could be what's important years ago. So let's do a little bit of Google search. Let's see how it works. So I'm going to highlight this, go to a new tab, and I'm going to Google it. And I think these names show up here, right? And it turned out Google is actually not completely wrong on this. There is an actual title called Natural Language Processing, although not understanding, with Python. And then these are the three authors. So in other words, what Gemini has is some sort of search engine, as I expected, that somehow grabbed this information according to some sort of a keyword search, natural language understanding, and it happened to stumble upon this title that looks closer and looks similar to natural language understanding. So I think that's where the problem happens. That's where the error happens. Me personally, I don't think Google's Gemini is completely at blame here. I think it's just one of those caveat situations that perhaps we can improve upon. So that's one example. Another example I want to show you guys is handwritten formula. So here I wrote a loss function. That's essentially mean square error. Let's take another picture to see if Gemini can recognize handwritten letters. So boom, there you go. That's my loss function. Here it says y hat, right? Y is ground truth. Y hat is the educated guess from the model. And that is the definition of the mean square error loss function, or sometimes people call it square loss. So let's see what the Google's Gemini AI says. And boom, here we go. He actually says the picture shows the definition of the loss function for linear regression. Now, that's actually more information I provided on the picture. The loss function is a measure of how well the model fits the data. In this case, loss function is a sum of the square errors between the predicted values and the actual values. In other words, this sentence is exactly correct. It's the exact definition of what I wrote here in that little piece of paper. So not only does OCR exist in the backend of Gemini, it actually has some sort of natural language capabilities to interpret what's on those texts, which I thought is interesting. In other words, if you guys use AWS, AWS has an OCR module that's called TextRag. It's kind of like TextRag on crack, right? It takes what gets extracted from TextRag and do more on top of that extracted text. So there you go. I thought that's something interesting. Hopefully you guys like this video, and hopefully this video give you some idea of what Gemini is able to do. If you like the video, stay tuned, and I'll see you guys in the next episode.